Ray, Logan, Emily, Hope, Coram. I think I got everyone, but I'm going to start off with the architecture intro. So the SQL Server's primary query languages are TSQL and NCSQL, and the scalability of the server's architecture is its most attractive feature because it was built to run equally in a wide variety of environments, whatever environment the primary user wants to throw it into. So this right here is just a quick picture displaying the overall architecture of the server, just to help you visualize as we discuss it. And then, so one thing that it runs with is tabular data stream, also known as TDS, and the clients that are connected to the server do so using TDS with a proprietary format. And the TDS is a Microsoft-defined protocol that describes the specifications as to how the SQL server and a client can communicate. And TDS also will describe what type of data is able to travel. And in transit, TDS is encapsulated within another transport protocol known as TCP/IP. And there are two engines or two components that the SQL server relies on for its management system. It's the relational engine and the storage engine. The relational engine's primary responsibilities is within its processing and data retrieval. The tasks that it completes are initiated by user queries, and it include parsing SQL data, optimizing execution plans, and retrieving results for the users when requested. And the storage engine's responsibilities are to ensure effective management of files, memory, recovery, logging, and transactions. And the storage engine assures that memory is available and being allocated appropriately to ensure there are no errors and that files are being utilized effectively and stored correctly. And there are three types of files within an SQL server used to store data. There are the primary data files, the secondary data files, and log files. And each installation has at least one primary and one log, so you could run into a server having multiple instances of those two files. The primary file is essentially the main data file, and it references all other secondary and log files within the server for the entire database. And like I said before, there must be at least one instance of it in order to operate. The secondary file is optional. It's not required within the SQL Server database, but it is an option there for that another data file, and it can be a secondary file extension. The log file stores information about the transactions in the database to be used for recovery and backup. And just like the primary file, there must be at least one of them. In an SQL server, there are two types of file groups that are used to ensure full functionality. There's the primary file group, which is a collection of files that contain all of the SQL Server files, including the primary data files as we saw previously, and then the user-defined file group, which is just a collection of files created by any user on the SQL Server. These can be organized into logical units of resources for whatever purpose you find necessary or suits your interests. The way these are used will be dependent entirely on the environment and what kind of data you store within them. Each database only has one type of file group.
So now for memory management, one of the most noteworthy characteristics that SQL Server has is that it can dynamically allocate its own memory without the need for an administrator to manually intervene. Each instance of SQL Server dynamically allocates its memory as it's needed without creating a shortage. And the goal of this storage is to limit the number of times that secondary storage is accessed. Hard disks are slow and are the most time-consuming storage, so by minimizing the amount of reads and writes to the hard disks, server performance will improve. And speed is maintained by maximizing the main memory and the system cache by using monitoring and balancing. The main memory is used for main database processes with the server, so although increasing the size of the storage a lot to the processes will help it maximize its use, using too much of it can create a starvation of memory for the rest of the system. So proper memory management is the keys to SQL Server's dynamically allocated memory. Virtual memory is a technique which extends the availability of memory where units of storage are located on different memory devices but are all used to store data from one entity such in a way that appears as if it's been stored on one block of data in the same memory. And the fixed units of storage that are transferred or swapped from one storage device to another are known as pages. And the page is a primary unit of data in SQL Server. They're often swapped from the RAM to the secondary form, such as a hard disk, to handle overflow and ensure that storage is being used correctly and efficiently. And the dedicated space for the page is known as a page file. So the virtual address space is the complete virtual memory allocated to a program, and the goal is to maximize the main memory without exceeding the available memory. So SQL uses a buffer cache in memory to hold pages that were previously read from the database. And the larger the size of the buffer pool, the fewer reads and writes to the hard disk that are needed. If the buffer cache uses up too much of the main memory, the result is that the operating system begins implementing virtual memory by swapping memory to and from the page files. And this process leads to fewer resources and increased performance. And there's two main components of SQL Server virtual memory, the memory pool and the executable code. So here's a picture of those two. They both make up SQL Server, but they work independently from each other. So the executable code is the server engine that within SQL Server contains all the executable and dynamic link library files, and you can see them all listed here. The memory pool is the total amount of memory available for an instance of SQL Server, and the size of the memory pool depends on how many applications are running. It changes the most changing portion of any part of an instance. And the memory pool fluctuates between the minimum and maximum value as it fulfills the needs of the applications that are using it, and it maintains a level of virtual memory allocated just below the true amount of physical memory. So you start with the amount needed and add in free memory as the applications instances and user requests fluctuates, but it never exceeds the maximum. There's 5 main objects within the memory pool. There's system level data structures, which stores all the data global to the instance. The buffer cache stores data page files from the database and to avoid reads and writes to the hard drive. Procedural cache stores execution plans for all current and recent SQL statements. The log cache stores pages that are read from and written to logs. And the connection context stores a record of the current state of the connection. Buffer management provides a location within physical memory where data is stored, minimizing the reads and writes to secondary storage, and there's 2 main components. The buffer manager is a portion of SQL Server responsible for accessing data pages and updating the database, and the buffer pool or cache is the area where data pages from the database are stored to minimize the need to read and write from the hard disk, and the reserved space for the buffer cache is called the memory target. So the process is that the request is made for data, buffer manager accesses the database files on the hard disk and retrieves the data. The data is placed on a buffer cache, and from there the data is read. If any changes are made to the data while it's in the buffer cache, the data is considered dirty, and a dirty page is one that's been modified within the buffer cache but has not yet been written back to the database. With each modification, a transaction row is added to the log cache to maintain recovery integrity, and once the transaction has been logged and the dirty page has stopped being referenced, the buffer cache frees the data and it's written to the database. So this uses threads and processes. A thread is a combination, contains tasks or exceptions that run independently from one another, but they share the same resources. And then we also have fibers, which are a subcomponent of a thread, and they are handled by the server to accomplish a task. They're not used by default, so you gotta configure them. And you have many fibers within one thread. An SQL Server keeps a pool of fibers or threads for all user connections, and these pools are called worker processes, and they can lower resource consumption. So some changes in TSQL, one of the primary server engine languages that it uses. In 2012, it introduced support for Windows functions, allowing for calculations to be performed over specific rows within the result set, like advanced calculations such as rank totals and rankings. 2016 introduced JSON support. 2016 introduced the string split function, which separates a string into rows based on a delimiter, which makes working with delimited data really easy. 2016 also introduced support for temporal tables, allowing for the tracking of changes made to the table over time. 2016 also introduced a query store, which helps track and optimize query performance by collecting stats. 2016 introduced scalar UDF inlining, which improves inlining UDFs within a query rather than executing them separately. And then in 2019, there were several new query processing features which improved query performance. Changes in tabular data stream in 2012 added support for SSL TLS. 2012 added connection resiliency, which had auto reconnection if you get disconnected, and retry logic. And 2016 introduced always encrypted, which keeps your sensitive data within the database encrypted and ensures encryption when it's being accessed by client applications. So the files, the concepts have pretty much changed the same, but the way they're managed has changed a little bit. 2019 introduced accelerated database recovery, which allows for faster recovery after a crash or failure, and this stores transaction logs, which speed up the rollback and recovery process. And then the other big thing with the files is the maximum file size was increased from 16 terabytes to 100, so you can have very large databases. Pages have mostly remained the same. 2008 introduced page compression, which saves on space, allowing faster reads and writes. 2016 also introduced row-level security, which allows more granular control over what users can do in tables and on specific rows. 2017 introduced resumable indexing operations, so you can pause and resume. This is important if you have big databases, so you can actually pause without having to restart. And 2019 introduced improved query processing, which I just talked about.
So here, we're going to go over installation, and this first slide is just going to be about things to be aware of, requirements. So in order to install SQL, you need to have the following as a minimum. You need at least a 2.0 gigahertz processor, 350 MB hard drive space, and 2 gigabytes of RAM minimum. Not all editions support the same operating system. Depending on the edition you have, you need to be up to date and ensure that you have the correct OS. But SQL will not install itself if you don't have the requirements or the prereqs. It will run a system beforehand and will either allow you to advance through the wizard, or it will stop and tell you what you need to fix. You also need the following software to be installed. You can either have the current version or what is the minimum requirement, such as the Net Framework, Internet Explorer, latest PowerShell, and Microsoft Data Access Components. All of these can be easily accessed through updating your Windows device or from an internet download. So some new features from 2019 include that Polybase, one of the steps you'll see on the next slide, no longer requires that Oracle JRE be pre-installed on the computer prior to installing the service. It now will take you to an install page for Java, letting you choose the location and the version that you want to use, either JRE, Java Runtime Environment, or JDK, Java Development Kit. Java has also been added within a language extension within the installation wizard, letting you choose between Zulu, OpenJRE, or provide a different location or version, or able to choose JDK over JRE. Right here in the installation steps, you see that you just want to follow through the wizard, agreeing to the addition, terms and conditions, kind of how you sign up for almost every service that you install. And then you will follow the installation steps, making sure you're installing in the right location, you have all the setup files, and you will connect on an Azure extension for your SQL server. Prior to all this, it will run that instance to make sure that you have the required prereqs. Like I said before, it will stop if you don't have those. You can select the features and components that you want specific to your SQL to your server, and depending, you're able to install the default instance or named instance if you already have one beforehand. And then right here at step 10, you can see that you won't need to follow that step if you are going with the current 2019 version, or past or post 2019. And then you would also make service accounts, determine who's going to have what kind of access for the SQL services. Engine configuration, specify the security mode and the server administrators, making sure that you have conditions and controls over who has how much power. Account provisioning to select the server mode and who has administrator privileges. And typically upon finishing installation, it will give you a summary log so you can just keep track of everything as you need. And sometimes you will be instructed to restart the computer.
Alright, so we're going to talk about the 2008 version, or the books version. So auditing can be created at the server level or the database level. It can be enabled, relevant, and created using the Object Explorer in the SQL Server Management Studio. The book also says that to create audits in Microsoft SQL Server, an administrator needs to be the one to create the server audit object to record the server or the database level actions that are desired. Next, a specification object needs to be created that will belong to either the server audit object or the database audit object previously created. As for 2016, a lot of things have changed from 2008 to 2016. So there are 5 different additions that both the SQL server audit object and the database level audit specification object includes, which are Enterprise Standard, Web, Express, Advanced version, and then just Express. SQL Server 2016 has all of these groups included in its update. In addition, it also has user-defined audit, audit filtering, and audit resilience. All editions of the SQL Server support server-level audits. All editions support database-level audits, beginning with SQL Server 2016 SP1. Prior to that, database-level auditing was limited to Enterprise Developer and Evaluation editions. Because of the overhead involved in enabling transaction-level auditing, starting with SQL Server 2016 SP2 CU3 and SQL Server 2017 CU4, transaction-level auditing is disabled by default unless you have common criteria compliance enabled. And then continuing with the common criteria compliance, it needs to be enabled if you do intend to configure any auditing actions from transaction group. For the 2017 version, this is again including the 5 different editions for both the SQL Server audit and the SQL database level audit objects. 2017 also has security innovations to help secure data for mission critical workloads, with a security approach having layers of protection. This update added always encrypted technology as well as row level security, dynamic data masking, transparent data encryption, and robust auditing. As for the BI version, another approach to use BI is to create reports that provide quick visual insights into the data. Although BI is not designed for auditing and alerting to the same degree as some of the more robust log management tools, it does provide a relatively simple method for tracking user behavior. Using BI to visualize SQL Server audit data can provide you with a powerful tool for reviewing the logged information in a quick and efficient manner. Moving on to 2019, again you'll see the 5 different editions which the SQL Server audit object and the SQL database level object has. As well in the 2019 version, the SQL Server audit object can be implemented if a business wants to add an auditing strategy to satisfy certain regulations. These regulations can include HIPAA, SOX, and PCI DSS. With this feature, you can ensure accountability for actions made against your SQL servers and databases. You can also store this log information in your local files or the event log for any future analysis. Moving on to the server 2022. Again, those 5 are included because whenever the 2016 version was added, these became standard. It's also recommended that users generate audit reports from a separate instance of SQL Server, such as an instance of SQL Server Express, to which only audit administrators or audit readers have access. By using a separate instance of the database engine for reporting, you can help prevent unauthorized users from obtaining access to the audit report.
Okay, so for authentication, we'll keep it super simple. There's 2 main modes that'll kind of remain constant from 2008 all the way up to its current version. The first one we have listed here, it's the Windows authentication mode. This is basically known as the trusted version. So there's the trusted version and an untrusted version. Those are the 2 takeaways that you're gonna get from what I say. For the Windows authentication, you basically just use your Windows login, and it's kind of just a simple, you log in with that, and this is pretty constant all the way 2008 to its current version. The mixed mode authentication, also known as the untrusted authentication, there's 2 different credentials that you're gonna have to log in. The first one, it accepts both your Windows authentication and also the SQL server. The reason this is untrusted is because there's just more credentials to keep track of, and there's a lot of complaints about that. The 2016 version, the Windows authentication mode has been updated to allow groups of those that hold Windows accounts to be added as a group instead of only individual. More details under that, however, that's like the biggest takeaway for 2016. 2017, I did not find any apparent changes from the previous versions. There's still the constant trend of either using the trusted authentication or the untrusted. Both are fine to use though. The BA version, the 2 options of authentication are either Windows or Basic. I don't know if they quite changed the name from the mixed mode to Basic, however I think it's the same, but for the BI they call it the Basic mode. Windows is logging into the server using your Windows account, as I've said, and Basic is similar to the mixed mode, but Basic authentication requires what is known as SQL authentication. It doesn't pull credentials from your Windows account like the first option does. You choose one of these, and then you also have the option for the BI version to use Kerberos SSO, which allows you to use a set of credentials for several different things in your systems that you select. So we're still running with the same 2 constant themes, trusted versus untrusted. The 2019 version, there's 2 authentication modes that are offered, the Windows or mixed mode. And I gave kind of just how to go about doing that. I'm not gonna run through that because I think we'll probably share these slides. So it's not worth going over that right now. The 2022 version, this is the newest thing that is added on top of the trusted versus untrusted authentication, which is the Azure Active Directory authentication. It's not required, and after you create your account, you can always add it later. But you're using your Azure AD password and your Azure AD. Oh, these are 4 different ways of using that, I'm sorry. You either can use your password, you can do Azure AD integrated, which is when if you log into your Windows account as well as your Azure ID, this is the type where Windows credentials are used. Azure AD Universal with MFA, so the multi-factor authentication. And then lastly, there's the access token. This is mainly for non-Go users, so probably not most of us here. And then there's a link for more on that.
Okay, so authentication and user accounts are very closely linked, so a lot of the content that's similar to authentication is going to be linked to user accounts. So starting with the 2008 version from the textbook, the way that default user accounts are configured is that upon installation, there's predefined user access, so the immediate users that are available on the system, immediate installation are the system and admin accounts. And so they have virtually no restrictions on them, and they have default settings for the username, the password, their privileges, what they can access. And like I said, since those accounts can access pretty much anything in the database, they can configure anything, delete or add whatever they want to. A big security risk is if you don't change these user accounts from their default credentials, these are public knowledge. So if you don't change this, it could pose a severe security risk if someone is able to get into your database and just do whatever they want with it. So a good security tip is to change that as soon as possible. The next big stable installation for SQL Server 2016, the kind of general rule of thumb that went from 08 to 16 and then going forward was that if you wanted to update the server for user accounts, the login credentials, if you wanted to carry them over from the previous build, you would do this using SQL queries to move them from the table allocated for user accounts from the 08 build to 2016. As mentioned with the authentication, there is the Microsoft authentication mode and the mixed authentication mode. So if you want to just configure it to have the Microsoft authentication login for the new database, you update from 08 to 16, you can do that. Otherwise, for the mixed authentication for any SQL authentications for the user accounts, you would just transfer that over, like I said, with an SQL query. So for the 2017 version, one of the big changes to the SQL Server is that now it's compatible with various distributions of Linux. So some examples provided are Ubuntu, Red Hat, OpenSUSE, and Docker Engine. And so because of the fundamentally different architecture of the Windows, Microsoft structure and the Linux structure, there is kind of a big overhaul in how that meshes with the Linux architecture and also how users are stored, because as we previously established, there's the Windows authentication mode and the mixed authentication mode. Well, you can't have a Windows authentication mode on a Linux server because it's just common sense. So it'd be capable of using the Linux username, password, and account structure to log in as well. So for the SQL Server BI edition, this is optimized for more corporate use and for businesses in general. And so any kind of tweaking to the user accounts would be optimized for that purpose. And then obviously this build was from 2012, so it's just kind of a derivation of it. For the 2019 build, it's more so just minute security additions, not too much change in terms of how default users are established or any of the fundamentals. So a big addition, however, that was in the 2019 edition was that it's encrypted with security enclaves, and so it has data discovery and classification features. And so it helps really secure access to default user accounts and any configurations you made with it. So then finally, for the 2022 build of SQL Server, one of the biggest additions to it is the buffer pool parallel scan. And so this can greatly help mitigate the risk of a buffer overflow in the database. So whether that's just overuse from people accessing the database, or it could be a denial of service attack if you're facing, this helps kind of greatly reduce that risk. As we previously said, SQL Server upon 2022 is now compatible with Microsoft Azure. And so this is their cloud computing platform. So in this installation, you can use the Azure Active Directory authentication, like we said before. So this also limits the vulnerability that could be exploited from access to one kind of credential. You can use that as well. Obviously, there's trade-offs for whether or not you want one or several login credential strategies. So that's up to the database administrator. Another set of policies that were integrated for this build of SQL Server was the Microsoft Purview integration data owner policies. And this allows access to all data sources belonging to a resource group or subscription, and can be essentially controlled from Azure Purview. And this is all managed from a single window, so the way that the administrator can manage that is much more streamlined. And as previously established, Azure Active Directory is available for this, and so the way that user accounts can be managed fits right into that perfectly.
All right, so now we're going to be going over password policies. So for Microsoft in general, they tend to stick to certain guidelines for all their services when it comes to password policies. And then based on the service you're using, there might be a little bit more or a little bit less. And then also depends on your organization and what their standards are for password policies. So that's where you'll see the main differences. From version to version that we actually researched, there wasn't many differences between the password policies. So with the 2008 version, like I just said, SQL Server can use the same password policy methods as available within the actual Windows server. There's 3 policy methods that go with it: password complexity, password expiration, and policy enforcement. So for the 2008 version, some of the password complexity guidelines should not include common words, reserved words, or account usernames. It should be between 8 and 30 characters, but can also be as long as 128 characters. Passwords can include the underscore, $, and number sign, and at least 1 digit of alphabetical character must be included with a password. However, a user cannot begin the password with a number. So for the password complexity of the 16, 17, BI, 19, and 22 versions, password complexity policies are designed to deter brute force attacks by increasing the number of possible passwords. When password complexity policy is enforced, new passwords must meet the following guidelines. Some of those guidelines are: the password does not contain the account name of the user, like I just previously stated, at least 8 characters long, Latin uppercase letters, capital A through Z, Latin lowercase letters, lowercase a through Z, and base 10 digits, and then also those special characters on the bottom. And once again, passwords can be up to 128 characters long, and use passwords that are as long and complex as possible is recommended. Okay, so when it comes to password expiration, the policies are used to manage the lifespan of a password, and when an SQL service enforces password expiration policy, users are reminded to change old passwords and accounts that have expired or have been disabled. So the password expiration settings can be customized based off the user's policies. Password expiration can also be disabled as a whole. So once again, that's where it comes into like your organization and what their standards are, and they can set their own expiration length for the password policies based on what you're working with or what type of account you have. And then once again, I don't know why anybody would put this into play, but you can disable password expiration as a whole. The default password expiration time is 42 days for this service, obviously meaning after 42 days, users cannot use that password anymore. And so this is where you can kind of see that from service to service, things start to change up within Microsoft. Because, for example, Office 365, the default password expiration is 90 days, versus this is obviously 42 days, as I just stated. And now for policy enforcement. So the enforcement of password policy can be configured separately for each SQL server login or user account. So you can use a user login or the ultra login function to configure the password policy options for SQL server account. The following rules apply to the configuration of password policy enforcement. So when check policy is changed to on within settings, the following behaviors occur. Check expiration is also set to on unless it is set to off on a different base. So that means it's always going to check the policies that your organization has set. Check expiration is also set to on, which means there is going to be an expiration length there. And the password history is initialized within the value of the current password hash. So it is going to keep track of the passwords that you have been using in the past and make sure that you are not trying to use those passwords again. And then 3 other things that are checked on when that's being used: account lockout duration. So that means there is going to be a set duration of time where you are locked out of your account when it comes to a certain amount of failed logins. And then account lockout threshold is how many times you can fail an attempt before you are locked out of your account. And then reset account lockout counter after is also enabled, and that means the amount of time that it takes for you to get back to 0 failed login. So it'll reset to 0, and then you can start to try and log in again, but it's going to take a certain amount of time to get to that point. And then when check policy is changed to off, the following behaviors occur. Check expiration is also set to off, so there will be nothing checking the expiration date of your password. The password history is cleared, so it's not going to keep track of the history of your password. So say you forget your password and you go to change it, and you might change it to the one that you were previously using, but it's not going to bring up a notification for that. And the value of lockout time is reset, so you're always going to be able to reset your password no matter the time.
On to roles, the 2008 or the book version. So all roles in SQL Server are either server roles or database roles, and the difference is really important. Server roles are meant to allow the login account to change the overall environment of the server, while database roles are meant to allow the user account to change objects within the database itself. Not much outside of the database though. The 5 main roles of the SQL Server are the fixed server role, which is the predefined privileges that create a role for each user account. They cannot be changed or deleted, but they can be added to. The fixed database roles, it's similar to the fixed server role as in how they are granted. However, they are different because these roles have more to do with access within the database itself. There's the user-defined role. These roles are related to the database and specifically the access and use of objects within the database. The application roles, this role supports security within the application. They grant permissions to software applications, which mainly require passwords, and this is also why the distinction between this role and others is important. And lastly, there is the public role. This role applies to everyone within the database, and it's used to assign a role to many users at the same time.
So for 2016, 2017, BI, and 2019, the nice thing about this is that the roles are all pretty constant over those years. The fixed roles were the same throughout the versions. The 9 fixed server roles, this is specific, this is different than the last 5 that she just talked about. They are listed here. And additional roles were added to the 2022 version as compared to previous versions. And they are roles such as the database connector, login manager, database manager, server state manager, and on. And then this is just kind of an image that kind of wraps up how roles are. Some roles do share certain things, like the disk admin and the server admin can share the ability to alter resources. So this was just kind of a nice thing that we found in our reading that kind of shows how roles are either separated or how roles share certain characteristics with each other. And this is all for 2019 and before.
Alright, so last but not least is user privileges. These are very related to roles. Roles have certain permissions. The textbook defines 3 levels of permissions: server level, database level, and object level. And the permission commands to grant permissions have been pretty unchanged from 2008 to 2022. Grant means you have permission to do some object. Deny blocks access and trumps all of their actions. So if you have a grant and a deny, the deny will win. And revoke undoes a permission, whether it's a grant or a deny. So how to change user privileges: the syntax is grant, deny, or revoke privilege, whatever you want them to be able to do, on an object to a user. You can also follow these steps in the Enterprise Manager GUI, which is just an easier way to click buttons and have a nice interface. So some common single select permissions are select, insert, update, delete, alter, references, shutdown, and control. Probably don't know references is used with foreign keys. Shutdown can shut down the SQL server, and control can use select, insert, update, delete, and reference. So server level privileges allow users to access certain tasks at the server level. They're fixed, means they're predefined and grouped by the SQL server to fit the needs of specific user accounts. They cannot be altered or removed and are only meant for specific accounts that exist on the server. It's important for admins to become familiar with these privileges to avoid redundancy, making sure you don't have 2 users doing the same thing. So for example, sysadmin is a default account created with SQL Server during installation. The account is assigned a fixed group of privileges meant to meet the needs of the system admin, and changes cannot be made to the account. So 2008 versus 2016, those are pretty much the 2 big years where stuff started to change. All the roles and server level permissions that we see today in 2022 were mostly introduced in 2008, and 2016 introduced 2 new roles that were not in 2008, setup admin and public. So these are some of the roles that and permissions that were talked about before. So sysadmin can do anything. Server admin can change server-wide configurations and shut down the server. Security admin manages user logins and permissions. Process admin can end running processes, and bulk admin uses the bulk insert command. Disk admin manages disk files, and DB creator can create, alter, drop, or restore any database. And then there's 2 new roles in 2016 were setup admin. They can add or remove linked servers, and public is assigned to objects without roles. They inherit all these permissions, so they should be set pretty low, not much access. SQL Server 2016 versus 2022 server level permissions. 2022 introduced new security roles meant to improve and make security management process easier. New 2022 roles provide more granularity and control over specific tasks, and the new 2022 roles start and end with a double hash signal indicating that they are system-defined built-in roles and managed by a SQL Server system. And these 2022 roles did not replace any of the new roles from 2016. The 2022 roles are new, just additions. And the DBA can choose which roles and permissions to use in different instances. So here's some of these new fixed server privileges and roles from 2022. database connector, login manager, database manager, server state manager, and server state reader, and their permissions there. And then we also have more server performance state reader, server security state reader, definition reader, performance definition reader, and security definition reader. So next we have database level permissions. These are granted either fixed like we just saw in single statement. Fixed is the same as server level, predefined by SQL Server to meet the needs of specific user accounts. And privileges can also be single statements which are granted manually to specific users using the syntax that we saw before. And these are like groups in Microsoft Windows using role-based access control. So 2008 versus 2016, database level permissions, about half the server level permissions that we see in 2022 were introduced in 2008. SQL Server 2016 introduced 4 new roles that we did not see in 2008: data writer, data reader, data denier, and deny data writer. So here are some of the roles for database level and their permissions from 2008. Database owner can perform pretty much anything. Security admin changes role membership. Access admin can remove access to the database for Windows. Logins, backup operator backs up. And DDL, this one's important to pay attention to. They can run any data definition language command on the database, so they could use commands to elevate their permissions, so they should be monitored more closely. And then we also have data writer, data reader, deny data writer, and deny data reader. 2016 versus 2022 database level permissions. The database level permissions have changed to increase security and granularity. They provide simplified role management, improved security, more granular permissions control, collaboration features, and integration with other security tools such as next generation firewalls and intrusion detection systems. And new roles have been added or deleted from 2016 to 2022, but some were changed, like data reader and data writer were changed to allow more granular control over data access. Object level permissions are granted the same way as the other roles using SQL statements or Enterprise Manager. There's no fixed level privileges by default. The object owner controls who has specific privileges on specific objects such as database tables. We use procedures, database events, and more, so that it's more than just tables and databases. The owner of the object can grant or revoke object permissions and can grant others permissions to grant permissions to others. So there can be 2 owners. There are no changes from 2016 to 2022 since they're not defined. There's no predefined. They're pretty much outside the scope. So some best practices for permissions is the biggest security concern is the way permissions are managed. You need to make sure that permission audits are happening regularly to ensure that the principle of least privilege is being followed. You need to ensure that terminate users are revoked to access from the database as soon as they're terminated. You should not have replicating permissions where you have 2 accounts doing the same thing. You should have separation of duties. No one person should have control over all of the system. Some legacy security problems was in 2000 servers or earlier, only anyone in the admin group on Windows would be made of the sysadmin fixed server role. This group should be removed from the sysadmin server role other than the database administrator and people who need it. This was fixed in 2005, and the local admin group was not made members of the sysadmin fixed server role by default. The installer asks for groups or logins that should be members instead of doing it automatically. And the last thing is stored procedures that have weak permissions can return passwords as they sometimes store passwords. That is it.
Any questions? Questions? Okay. Thank you very much.